right, all this is the 2018 released sample items for Module 2, multiple choice. So 12 of these questions. Starting with number 1. Chef Bailey measured the internal temperature of a whole chicken during the first 60 minutes of cooking time. Good for Chef Bailey. First 60 minutes. The pattern in the temperatures she measured is shown in the table below. So basically we're given a table. Cooking time, temperature. The pattern continues. Which graph best represents the pattern? So if you were to, so which graph matches this table? If we were to graph this table, wouldn't we just graph all of these pairs as points? So cooking time is X as it should be. So 15, 80, 30, 100, 45, 120, and 60, 140. Oops. So, graphing those points, those 4 points, it looks like this graph with this line definitely matches it the best. So that's all it was. Matching a table to a graph is about all of these points, all these pairs, like 15 with 80, 15. So like 15, 80, that's this point, or I guess in the correct answer, this point. There's 15, 80. Here's 30, 100. So here's 30, 100. Here is 45, 120, and 60, 140. Number 2, which set of ordered pairs is a function? So something you might want to write down, I suppose, is that for something to be a function, there can be no repeat x values. So which one of these choices, so you're just going to check all the choices out. Which one of these choices has no repeated x values? Ooh, fail. That's a fail. Oh, there's a fail. Oh, here's a fail. So it must be D, but let's make sure, shall we? -1, 0, +1, +2. Oh yeah. That's all it takes. A function has no repeat x values. Laura drove her car. Yeah, good for Laura. Yada, yada, yada. We have this table of values. And the bottom line here, because look at the question they're asking. What is the range of the relation in the table? The range is just all of the y values. Remember, domain and range. Domain is all the x's. Range is all the y's. So 15, 10, and 8 in order would be A. That's all it is. Range is all of the y values. All of these values. You know, all the output or whatever. Column number 2, in other words. Number 4, Paul inherited a stamp collection. Good for Paul. Since receiving the collection, Paul has gone to the store and bought the same number of new stamps each week to add to his collection. So he inherited a stamp collection, and each week he goes to the store to add. Okay. The equation shown below can be used to determine the number of stamps y. So the y variable is for the number of stamps. And the x variable is for the number of weeks after he inherited. So number of stamps will equal 3 times the number of weeks plus 40 based on the equation, which statement is true? Looks like we're just going to have to go through the choices one at a time. The stamp collection had 3 stamps in it when Paul inherited it. No, like the number 3 that's being multiplied to the number of weeks, that 3 should represent how every week we're getting like that many more stamps. You know, like if X is the number of weeks, you know, what would you multiply by the number of weeks? You would be multiplying by maybe this in choice C. Since inheriting the collection, Paul has bought 3 new stamps each week. I'm liking C. I didn't like A. Let's see. So let's check all of them though. We gotta be sure. So choice B. So far, Paul has purchased 40 additional stamps for the collection. No. No. If the total number, like, let's look at this equation again. If the total number of stamps is going to equal to the number of weeks times 3 plus 40, this plus 40 must have just been there in the first place, like a one-time thing. So I would believe that there was 40 stamps to begin with. Do any of these choices say that? Let's see what choice D says. 6 weeks after he inherited the collection, Paul's stamp collection contains 18 stamps. So if you let X equal 6, so 3 times 6 plus 40, no, that's not 18. So I guess I'm liking what, C? What did I like? Since inheriting 3 new stamps each week. Yes, that's what, yeah. Every week, X weeks, every week you get 3. Number 5, function of X. Okay, so we got this graph and we got 4 tables. Which table matches the graph? So basically, which table contains points that would be on this line? So like this table says -8, 19. Would -8, 19 be on this line? Tough to say. -6, 15? Tough to say right now. -4, 11, -2, 7. If this is the correct table, then all those points would be on this line. Choice B, -8, 50. Ugh. -6, 38, -4. So would these 4 points be on the line? Would these 4 points or these 4 points be on the line? So that's the bottom line, but considering, you know, even like -2, -2, gosh, even that's like not super easy, super clear. So here's what we're going to do. We can take all of these tables and figure out if the slope, right, the rate of change, the slope, matches this slope. This slope is supposed to be, what, like maybe from here to here, down, let's see, that's 5. So that is down 2. That is down 2, and is it really over 1? Yeah, 1, 2, yeah, okay. So it really is down 2 over 1. So the slope is -2 over 1, -2. When you look at, let's see, the change in y, this would be like down 4 as x increases by 2. So down 4 over 2, remember it's change in y over change in x, not the other way around. When you, and again, I'm assuming you've already looked at this and either got stuck or you have an answer and you're just trying to make sure you're correct, right? You shouldn't be coming into this video completely cold. Losing 4, gaining 2, okay. Alright, so apparently these slopes, you know, the change in y compared with the change in x, does not match the change in y and change in x slope for the graph. Okay? So the next thing is, which one is it? A or B? Does negative 2 comma 7 make more sense, or negative 2 comma 10? Well, negative 2 comma 7 is right there, so it's probably, what is this, C? It's probably C. Yes, it is. But one more way to tell is like, well, we know for sure 0 comma 6, right there, the y-intercept, 0 comma 6. So as far as these tables, look, negative 8, negative 6, negative 4, negative 2, 0. If there was one more xy pair in each of these tables, it'd be 0 comma what, right? So 19, 15, 11, 7. If we keep losing 4, it'd be 0 comma 3, right? But this would be 22, 18, 14, 10. This would be 0 comma 6. So that's just, I don't know, numerical confirmation that this table would contain 0 comma 6 and not 0 comma whatever, or that, that negative 2 comma 10, negative 2 comma 10 is much better than negative 2 comma 7. So this matches slope. And, at the end of the day, all of these points, again, let me circle back to like the most black and white reason why this table matches, because all 4 of these points, not just negative 2 comma 10, but negative 4 comma 14, negative 6 comma 18, and negative 8 comma 22 would be on this line. It's all about the points, baby. A caterer uses 4 pans of lasagna to serve 30 people. Good for the caterer. At this rate, okay. I underline the word rate because you have to realize that in Keystone lingo, the word rate is synonymous with slope. So rate means slope. You should write this down maybe for studying purposes, but rate means slope. And so at this rate, how many pans of lasagna does the caterer use to serve 390 people? So bottom line, it's like 4 pans for 30 people. You need the same rate. You need like it's the same slope, which basically means like the same fraction. Okay? So 4 pans over 30. So 4 over 30 would be the same as what over 390? Bunch of different ways you could do this. You could just use maybe common sense, or I don't know. You could cross multiply. You could just actually see that 4 divided by 30 is something. Let's see. 4 divided by 30. Got my trusty calculator here. This is like 0.133. And so you could just check all 4 of these and do 13 divided by 390, and then 52 divided by 390, and then 90 divided by 390, and then 98 divided by 390, and see which one of these, you get a bingo on that 0.133. Or like I said, or you could cross multiply and get 4 times 390 equals 30 times question mark, or 30 times x. 4 times 390 is 1,560, I do believe. And so 30 times question mark, or 30 times x. So then you would divide both sides by 30, and it looks like you would get, question mark equals 52. So the answer, of course, is going to be B. Makes sense, right? To serve 40 people, what did I say? To serve 30 people, you need 4 pans. To serve 390 people, it'd be like that. It'd be like a common multiplier, you know what I mean? That'd be yet another way to figure this out. Thinking like, okay, so 30 people became 390 people by multiplying it by what, like 13 or something? So you'd also multiply the pans, 4 pans, by 13, and you get 52. So B. Which linear equation has the points 1/2, 3/4, and 4, 3 as solutions? Remember, the word solutions means that this would be an x and this would be a y, and this would be an x and this would be a y, and both of these xy combos would plug into the correct equation to make that equation true. Okay, so that's one way to do it. It's not a lot of fun, to plug 1/2 in for x and 3/4 in for y and see if it's true. But then you would also have to plug in 4 for x and 3 for y. So here's what we're going to do. We're going to do it the straightforward way. Like the non-multiple choice cheating way. And let's figure out m by doing, the typical slope formula. So 3 minus 3/4 over 4 minus 1/2. And so it turns out that the slope is 9/14. Okay? Now, let me take a breath here to address something. These two answer choices, C and D, those are in a form called point slope form. Now, you might have been trained to write equations, right? If they give you stuff to work with and they want an equation, you might have been taught to plug into slope-intercept form. Like you might have been taught to plug in the slope for the m and take a point and plug in for the x-coordinate in there and the y-coordinate in there and figure out b and yada, yada, yada. But considering that C or D might be the correct answer, hey, this is a little bit of evidence. Remember, this is literally a question that the people that write the Keystones released as a practice problem. And this problem is really, 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 kind of hinting that you need to know what this form is all about. So we're going to go with this form, not this form. And how do we plug in for this form? Well, the slope goes in for m, and we take any point, and let's go with this point, right? Definitely, let's go with this point, not that point. And we're going to plug in for x1 and y1. So that's how we plug into point slope. We plug slope in for m, and we plug the coordinates of any point in for x1 and y1. And we leave x and y as x and y. And so taking this x-coordinate and this y-coordinate as well as this slope gets us to here. Y minus 3 equals 9/14 over x minus 4. And let's see, 9/14. We already knew it was not going to be, we knew that wasn't our m. We knew our m was 9/14. It's not D either. Oh man, it's one of these. A and B are in standard form. So we just have to take our answer and keep this going and keep rewriting it until it's looking like one of these answers, which are in standard form. So the next thing would be to distribute the 9/14. That's what I'm going to do anyway. So my next move is to take the 9/14 and clear the bubble with the distributive property. Okay? And I got some nasty fractions, and it's pretty much inevitable here that we're going to have to figure out a way to clear the fractions, if that's how it, And here's what we're going to do. In order to rewrite this without fractions, I'm going to multiply both sides of my equation by 14. Doing that, and that's going to, and I'm allowed to do that, and what that's going to do is it's going to clear all the fractions on the right side, but again, whatever you do to the right side, you also have to do to the left side. So the entire equation is going to change like that, multiplying both sides by 14. So that's going to become 14y minus 42. And on the other side, when you do 14 times 9/14, the 14s cancel, and you're just left with 9x. See the fraction clear? No more fraction. And when you multiply 14 times this, the 14s cancel, and you're just left with 36, or to be more specific, negative 36. And so we're still not done. I'm out of room here on the screen, but we're nearly done. So what would happen next? All right, I mean, I'd have to put this in standard form. Would I move the 9x to the left side? I could, but that would be, I'm thinking ahead here for you, but that would be like a negative 9x, a negative 9x. And look over here, these versions have positive 9x. How about I leave the 9x over here, and you would actually move the 14y over to there. So you would like subtract 14y over, so it'd be 9x minus 14y. I already know it's A and not B, because look, this is a minus 14y, and that's a plus 14y. So over here it'd be 9x minus 14y, and you'd have to add 36 to the other side. You know what I mean? So negative 42 plus 36, yeah, that's where the negative 6 comes from. So it ends up being A. Gosh, that was fun. Number 8, Martha. Why did they say that name? Martha earns money sewing curtains. Good for Martha. She charges a flat fee to meet with a customer and take window measurements and an hourly rate to sew the curtains. The graph below shows the relationship between the time in hours Martha works on a sewing project and the total amount in dollars she charges. So, for this many hours Martha works, relation between the time, so the time she works on the project, and here's the total charge. Okay, so we got a flat fee. So apparently, well, here, okay, let me throw in a random bonus concept or explanation here, right? So apparently, this flat fee, like what's her, according to the graph, what is her flat fee? This is an extra question I'm throwing in out of nowhere. What's her flat fee? So she got like this flat fee just because, and then after her flat fee, then she starts charging by the hour. So where would you find her flat fee on the graph? Well, guess what? You'd find it right here. Even if she spends 0 hours working on a project, looks like she's going to get $20. So right here, the y-intercept of this graph is her flat fee. So, and then after 1 hour, okay, anyway. But the question here, getting back on track, hourly rate. What does the word rate mean? It means slope. Rate means slope. Not just in Keystone lingo, but, well, that's what we're worried about right now, is the Keystones. So when the Keystones say rate, what they really mean is slope. So what is the slope of my line. That's all it's asking. So here we go. That's a nice point. Well, we'll use that one. That's a nice point. 2 comma 40. Here's another nice one. The further apart, the better, right? But I mean, look at this. Even there, it'd be bam. But yeah, whatever. So here's the slope. We rise. This isn't just 1. This is not just 1. We're going from 40 to 60. So this jump of 1 is really a jump of 20. From 40 to 60. $20 rise. The run is what? From 2 to 4. So the run is just 2. So $20 for 2 hours. $20 2 hours. If you were to reduce this, you'd get 10. $10 for 1 hour. So 20 over 2 is the same as 10 over 1a. Okay, so this fraction reduces to that. Number 9, a data set contains student test scores. Good for the data set. So student test scores. So the median, that's an important word. The median or the middle score is 75 points. The third quartile is 85. Remember, third quartile is another name for upper quartile, which is also another name for upper median. And then we have the range. Now this is not domain and range, this is range of a data set. So here the range is going to be the difference between the absolute lowest score and the absolute highest score. It's what you get when you subtract the high score minus the low score. So that means 40 points. So which statement about the test scores in the data set is most likely true? So our strategy here is going to have to be just check out each choice. Just read them all and which one's the best. The lowest test score is 45 points. I mean, maybe, but how? I mean, based on all this, I mean, look, the median. Let's look at it this way. Let me give you this spin on this, okay? This bullet point, the median test score is 75. All that really means is that 50% of the students or so scored below 75, but also 50% of the students scored above. So about or exactly half of the students scored below 75 and exactly or about half scored above. Since this is the upper median, then about or exactly 25% scored above 85 points. You know, the and then the range, you could say the difference between the low score and the high scores. Like you could say theoretically that the low score was 60 and the high score was 100. Like if one of these choices said that the low score was 60 and the high score was 100, I'd pick it. You know, if one of these choices said that 75% scored below 85, I'd pick it. Or if they said 25% scored above 85, I'd pick it. Well, let's see. Choice A, I'm not going to go choice A. The highest test scores, I don't know that for sure. Choice C, about 25% less than 55? I don't know. What? No. Choice D, about 25% of the test scores are between 75 and 85. That is basically the best answer because remember, these medians cut the data into 25% chunks. So if you had like, let me draw some kind of rough thing. Like if you had like data, like a score, a number, whatever, all those numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. So the median would be here. That cuts the data in half. The upper median would be 1, 2, 3, 4, 5, like right here. Like there's the upper median. Here's the lower median. So I mean, like, you got like basically 25%, 25%, 25%, 25%, because you got 50% above the median. So that's what we're talking about. 25% between the median and the upper median. Yeah, right there, 25%. D. Number 10, the scatter plot below shows 9 points from a data set. Okay, so here's a graph. The equation of the line of best fit is determined. Then 3 more points are added to the scatter plot, but the equation of the original line of best fit remains unchanged. Okay, which 3 ordered pairs are most likely the added data points? So basically, like, which one of these groups of points would fit whatever line of best fit? Okay, so let's just check them out. 4, 4. 4, 4 is like right there. 5, 5 ish. It's not looking like it's A, is it? 6, yeah, not looking good, eh? Let's try B. 4, 10. So 4, 10. 4, 10. Wow. Where did I have 4, 4? Whatever, anyway. So 4, 10, that's looking better. 4, 11. Okay. 4, 12. All right, that's looking pretty good, actually. So, but let's check them all. Let's be sure. 8, 9. Oh, God, no. 8, 9 would be right there. 8, 10 would be like there. 8, 11 would. Yeah, no. Still like in B. 10, 10. No, gosh. This is even worse. 10, 11. 10, 12. Yeah, it's B. It's B. Just had to check them all. Not too tough. Number 11, another scatter plot. Keystones love scatter plots. This one shows the relationship between the age of a house and the number of days it takes for the house to be sold after being listed for sale. Okay. The equation y equals 0.95x plus 17.56 describes this line of best fit for the scatter plot. Based on the equation, which value is most likely the number of days it takes for a 60-year-old house to be sold after being listed for sale? So, all right. So, which is most likely the number of days that corresponds with the house being 60 years old? Now, potentially, this is a prediction question. Keystones love to do this, okay? Keystones love to do this. They give you a scatter plot, and we're talking about a line of best fit for the scatter plot. They love to do predictions. Now, potentially, you could just eyeball the graph, because here's the number of years that the house is, the age of the house. So 60 years would be 35, 40, 45, 50, 55, 60. 60 would be over here. And so normally you could like go up to this line. So you could like extend the line and see what the corresponding... You could maybe pull that off. I mean, it's definitely not 45 because 45 is like right here, But oh man, I'm not going to recommend that strategy. extending your line over to here and then just kind of seeing where that line would be for 60 years and what would be the corresponding y value over here with the number of days. So here's my other option, okay? The better option, especially considering you have the equation right here, which literally says, since again, y is the number of days, x is the age of the house, this equation might as well say that the age of the house will equal 0.95 times the age of the house plus 17.56. Let me make sure I said that correctly. This equation says the number of days it takes to sell. So I might have said this wrong before. I don't know, but let me say it again just in case. The number of days it takes to sell will equal 0.95 times the age of the house plus 17.56. And then they're giving you basically an x value. Bam! Just plug in 60 for x because it's an x value. It's an age. Bam. Bam. Thank you very much. So crunch those numbers and you get 74.56 days it would take to sell. So by far the best answer here is C, 75. So again, remember, you can use the graph to make a prediction, but if you have the equation, just use the equation to make the prediction by plugging in whatever, okay? Now, just one more quick random thing, right, just to elaborate. They could have given you a y value. They could have said something like, okay, so how old would the house be for it to take 100 days to sell? If they would have asked that, if they would have asked that, how old would the house be for it to take 100 days? 100 days would be a y value. You would plug in 100 for y and then solve for x. Anyway, number 12. There are 28 students whose last names begin with the letters G, H, J, or K. Information about the probability of randomly selecting one of these students is listed below. Okay, 28 total students, that's important. This bullet is saying that the probability of selecting a student whose last name begins with G is 1 out of 7. So we have all these different possibilities. There's 28 students, and the probability of selecting someone whose last name begins with G is 1 out of 7. So in other words, 4 out of 28. 4 out of 28 is equivalent to 1 out of 7. Remember, probability is the number of favorable outcomes out of the total. So 1 out of 7 is what out of 28? 4. Because I already know that this final question, and you should too, because you should already looked at this. The final question here is asking how many of these students have a last name that begins with H. So if the probability of getting G is 1 out of 7, that means 4 students have last names begins with G. Okay? Because these fractions are equivalent. And this next bullet says the probability of selecting a student whose last name begins with G or H is 5 out of 14. Well, if you had to say like 5 out of 14 is what out of 28, how many actual students is that? That would be 10 out of 28. These two fractions are equivalent. And so that means 10 students have last names that begin with G or H. Well, when you combine these two bullets, common sense says that how many students have last names that begin with just H? Well, 6. So say. So that's an interesting little probability question, eh? And so that does it. That is all of the 12 Module 2 released sample items for 2018.